All right. I'd like to continue our discussion for time value of money and the discounted cash flow. So this is part two of this discussion. All right. Earlier, we discussed how to deal with single cash flows. Okay. We did a few examples about finding the future value of a single cash flow. In this example number four, we tried both the function and the formula. Okay, there are a lot of little things for you to be careful about when you apply the Excel functions. All right, so now let's continue our discussion for multiple cash flows. So I'm just going to denote this by MCF. All right, so first of all, a little motivation. All right, so why do we need to discuss multiple cash flows? Well, the simple reason is because many, cases, in many cases, we're dealing with multiple cash flows. For example, our mortgages. Okay, later we're going to discuss, mortgages in great detail. All right, stocks. Okay, stocks, they may actually pay quarterly dividends. So these are multiple cash flows. Okay, bonds may pay periodic coupons. So these are multiple cash flows as well. All right, annuity contracts. Okay, so this apparently it's another example of multiple cash flows. So you pay a lump sum today for the insurance company, and the insurance company will pay you a fixed amount in the future for, let's say, 30 years. Okay, and so on and so forth. All right, so these are all multiple cash flows. All right, so they are everywhere in the financial market, and that's why we need to study them. All right, so how do we actually deal with multiple cash flows? Okay, so or alternatively, how do we actually value multiple cash flows? So I like to actually bring up example number 7 here. Okay, I'm going to show you the methodology, and I'm going to show you, how you can actually model and to solve multiple cash flow problems very conveniently in Excel. All right, so let's just look at example number 7 on the lecture note. Again, it is a very good habit for you to actually have your lecture notes side by side when you watch the video lecture. Okay, example number 7. Would you pay $1,500 today to get a series of future cash flows in the following 5 years, assuming an interest rate of 6% per year? All right, so I'm just going to build a timeline and indicate the cash flows. All right, so I'm going to actually, this is a 5-period multiple cash flow structure. All right, so I'm just going to have 5 periods here. And then we have the cash flow per period. So in period 1, you're going to receive 100. And then in period 2, you're going to receive 200, 300, 400, and 500. Okay, so these are the cash inflows if you pay for this, call it an investment or call it a security. All right, so the interest rate is, all right, R is 6%. And the question is, would you pay $1,500 for it? All right, so that's the question. All right, so what's the analysis here? The analysis is apparently we want to decide whether this is a good investment. All right, are you willing to pay $1,500 in exchange for this following 5 cash flows? Okay, so really the question is you have to consider the time value of money here. All right, so the time value of money principle. Okay, what is this principle here? I'm sure you have discussed this in your first class in finance. All right, money has time value. So these, 100, in the first period, 200 in the second period, and so on and so forth, they are having their own timestamp. All right, so you cannot simply add them together. All right, if I simply adding them together, all right, so if I want to actually add up all these, cash flows, all right, I can actually do a sum function here, which is actually adding up these 5 cash flows. You see that you get 1,500. If you just add them together, you get 1,500. So you might be saying, you know what, I'm indifferent because I pay 1,500, I get 1,500. So it doesn't matter. Well, this is wrong because, what is wrong here? Okay, well, it violates the time value for money principle because all these cash flows, they actually occur at different time points. So you cannot simply add them, all right? You have to remove the different timestamp, okay? In other words, have to bring them to a common time point. And how do we do this? I'm pretty sure you have discussed this in Finance, 201. So how do you bring them to a common time point? Well, you can actually, choose to do this by discounting and or compounding, okay? So, only after you discount these cash flows, only after you bring all these cash flows to a common time point, can you then add all these, present values. All right. So, our methodology here is, okay. So, our framework, we need to find the present value of this multiple cash flow structure. Okay. So you see that in this case, you actually have a present value which is essentially 1,500. That's the amount you're paying, and you have all these following 5 cash flows. So these are actually cash flows in between. If you want, you can think of there might be a future value at the end of year 5, and so on and so forth. Well, in this case, the future value at the end of year 5 is 0. All right. Well, this might be confusing, so I'm just going to get back to our present value of this multiple cash flow here. All right, so the methodology present value of the multiple cash flow structure is equal to present value of each cash flow. Okay, added up. Present value of the cash flow in the first period plus present value of the cash flow in the second period, which is denoted by cash flow 2, and in this case, you have present value of cash flows in the 5th period. All right. So the question is, how do you get the present value of these individual cash flows? Okay. So just remember, every time when you're dealing with multiple cash flow structure, the simplest way to find the present value of the entire structure is to break this down into many individual cash flows and get the present value of each individual cash flow. Okay, so I'm going to start thinking about present value of the cash flow in the first period, cash flow 1. How do I do that? So, if I want to actually, understand how to get a present value of the first cash flow, then all I need to think about is there's a period of 0, there's a period of 1, and I am going to receive $100 in period of 1, and I want to find out, hey, what's the present value here? Well, some of you may say, what happens to the other 4 cash flows? Don't worry about it. I'll consider them later. For now, I'm focusing on the first cash flow in the first period. So, in our terminology, this is the earlier time point. We're looking for the present value. This is the later time point. We're looking for this is the future value. So we need to discount the present, the future value of 100 back to today. In other words, okay, all the present values on the right hand side, all right, are defined by using the common time point. Okay, so you can choose any common time point, but maybe the easiest one is to pick time point 0. Okay, in other words, I want to bring all these cash flows back to today. All right, so if that's the case, let me just insert one more row here. All right, so this is the first 100, and I want to get the present value of this one here. So I know if I want to actually do the discounting, so back to the treatment for single cash flows. All right, so the present value of a future value of a given future value is given by the future value divided by 1 plus r, which is 6%, raised to the power of 1, because the first of 100 will be received in one period. So that is $94.34. So this is telling you receiving 100 in period 1 is the same as receiving $94 today. Okay? All right, so I'm going to continue and I'm going to work out the present value of the second cash flow. All right? Maybe I should actually, have one more row here. Present value of the second cash flow. So now I'm dealing with a 0 and I'm dealing with a 2 here. And some of you will say, hey, what about the 1 here? Well, don't worry about it because we have already considered the first cash flow in the first step. So the other cash flows in periods, 3, 4, and 5, don't worry about it. I'll consider them later. So I'm going to receive $200 here, and I want to find, hey, what's the present value of the 200? So if that's the case, we're back to, single cash flows, and I'm going to do the formula here again. So that's going to be the future value divided by 1 plus the discount rate, which is 6%, raised to the power of 2. Yes, because you wait for 2 years or 2 periods to receive the second cash flow. All right, so that is $177.99. All right, so now I can actually proceed in this manner and say present value of the third cash flow, which is the the 300. So I'm going to look at my partial timeline here. All right, I don't worry about the first 2 periods because I have done them. I don't worry about the last 2 periods because I will do them later. All right, so that's 300 here, and I'm looking for the present value. All right, again, you know how to do this. So we're going to do the future value divided by 1 plus 6% raised to the power of 3, because you have to wait for 3 years or 3 periods to get the 300. So that is the present value of the third. Now I'm going to go a little faster. Present value of the fourth. So this is today. This is period of 4. And you're going to receive 400 here. So what's the present value here? All right. So this is really the 400 divided by 1 plus 6% raised to the power of 4. All right. So you waited for 4 periods to receive the 400. So I'm going to execute this calculation, and this is coming out as 316. So present value of cash flow in period of 5. So I'm just going to do the last one here. This is 0, this is 5, and I have $500 cash inflow here, and I want to find out what's the present value of this, fifth cash flow. All right, so this is equal to 500 divided by 1 plus 6% raised to the power of 5. So now you see that I have just manually calculated the present value of each of the following 5 cash flows. So present value of the entire multiple cash flow structure, that's going to be equal to the summation of these 5 individual present values. So that's the first one here, the second one here, the third, the fourth, and the fifth. Okay, I'm using the summation function to add them up. So this is the present value of the multiple cash flow structure. And so your conclusion is very obvious. It is not wise to pay $1,500 for this because in return, you only get $1,214.69 in present value terms. So if you, pay $1,500, you are overpaying about $300. This is a negative NPV project, negative NPV investment. All right, so I could have, wrapped up this discussion here, but you notice that this is rather cumbersome, okay? Because imagine if you're going to have 360, monthly mortgage payments, if you want to find out what's the present value of these monthly mortgage payments, well, you would have to do these 360 times, and that is really not efficient at all. So I start to think, can we actually find a way to streamline this process and in particular, can we just get one present value and copy across? Remember earlier, we discussed this, nice trick in Excel. You can actually build a formula and copy across. Okay, so the answer is yes. With a little extra effort, you can actually, to streamline this process, okay, and make it more efficient. Do it, the following way. All right, so I'm going to actually streamline this process, and I'm just going to copy and paste this, question, setup here. All right, so I just, highlight these, a specific data range. I press Control C, and I move down, and I press Control V. All right, so this is the question. So now I'm going to say present value of each cash flow. So can I just get the present value of the first cash flow and put it here? And after that, can I just copy this formula across and get the present value of the other 4 cash flows as well? All right, so the answer is, of course, as long as you are using the right formula, using the right cell reference. Okay, so watch me closely. I'm going to consider the present value of the first cash flow. I'm going to do the following. All right, so present value of the first cash flow. Well, look at this, a sketch work here. You're only focusing on the first cash flow. So this is a single cash flow problem now. So you're just going to treat the 100 as the future value, and you're going to do the discounting. So I'm going to take this 100, I'm using cell reference now, divided by 1 plus 6% raised to the power of 1. Actually, I want to use the time point 1 from the timeline. All right, so now you start to think about this formula. This formula actually is very strong in the sense that you can actually copy across. Okay, so let me execute this formula here. Yes, you get 94.34. That's the same number you saw earlier, and I can just copy this to one cell, and let's just look at what Excel did. All right, because the way we're using the cell reference, actually in this case, is referred to as relative cell reference. So when you actually copy this formula in D117 across to E117, this is what Excel is doing. All right, so let me actually decipher this process. So D116 is now become E116. Okay, and then divided by 1, well, 1 is a constant, so it will be copied over, and 6% is a constant, so it will be copied over, raised to the power of, so that, a little, operational sign, that's also copied over, and then D115, well, that's going to become E115. All right, so this is precisely what we're seeing here. So now I can actually become a little greedy and copy that across further. So now I get these 4, additional present values. Notice that I only did the present value formula once. Okay, so I'm going to say present value of all cash flows. All right, some of you will notice, why do you leave one row blank? I'll come back to that in a second. All right, so now I'm going to actually add them up. And just to emphasize, these present values are defined at the same time point. Time point is 0. So yes, I can safely add them. In other words, these 5 numbers, they are having the same timestamp, and that particular timestamp is time point 0. So yes, I can add them. So yes, you can actually replicate this, $1,214.69. All right. Some of you will wonder, can you actually do this, present value function here? Well, of course. All right. That's why I left the one row blank. All right. So I'm going to do the present value function here. The rate is 6%. So let me just type down 6%. Number of period here is 1 because I'm discounting the first cash flow. The first cash flow will be received in 1 period. And payment here, well, this is a single cash flow, so payment is 0. Remember what we said earlier for single cash flows. All right, future value, well, future value is 100. Well, that's a cash flow, and you're going to receive, so it's a cash inflow, it's positive. All right, and you notice that present value function actually has a type argument, and this actually is optional. As you can see, from this, a square bracket. Okay, so I'm going to skip that. I'm going to come back to that later when we discuss annuities. All right, so for single cash flows, it doesn't matter. All right, so we're just going to get the present value, and yes, this number is actually showing up, as a negative number. Why? Because you're signing the 100 as a cash inflow, so it's like you're withdrawing your deposit. So today you have to make your deposit. All right, that's the interpretation. But the numbers, they are the same. Okay, so I can actually copy this across, and I can say present value of all cash flows from the Excel present value function. All right, so that will be producing the same number here. Whoops. All right, so $1,214.69. All right, so this is apparently a lot more streamlined because I don't have to do this formula 5 times. I can just do the formula once or do the function once and then copy across. And Excel is going to spit out the answers or the present values for me directly. All right, so this is much more efficient. All right, I hope this is making sense to you now. If not, let's actually look at another example, number 8. Okay, this is a very confusing example here. So please, if you are a little tired, you can actually pause the video and get a little break and come back to this. All right. So let's just look at example number 8. Axel Heiberger has just signed a job offer with an annual salary of $24,000. All right. So he has decided to put 10% of his gross monthly income into a retirement account at the beginning of every month. All right, this is the timing information. The retirement account pays interest at the interest rate of 0.75% per month. Okay, and this person expects to receive an annual raise of 10% each year for the next several years. All right, so each year the raise is 10%. It's kind of constant. All right, you can actually think about the implications of having a constant raise. All right, how much will he accumulate in his retirement account at the end of 2 years? Okay, so what's the analysis here? All right, so if you look at this question here, this is fairly complicated. All right, but the thing here is, in Excel, you can easily adapt, the timeline and the methodology we just discussed to very complicated questions like this. All right. So this person is actually saving, and it's saving for 2 years, okay? And it's actually saving monthly, all right? So saving, savings per month. So in 2 years, that's 24 savings, okay? Every month this person is actually going to save. So in total, this person is going to have 24 savings. Well, that's a multiple cash flow structure, okay? So we're dealing with multiple cash flows. All these 24 monthly savings, that's a multiple cash flow structure. All right. And now, this is asking how much in 2 years. Okay. So really, we're looking for, well, the end of 2 years. So you can actually have this, multiple period of timeline here, and you're just looking for the future value. Okay, so that's what we're shooting for. All right, that's a very brief but a very important analysis. Okay, you understand the nature of the question, and you cast that question in our own framework. Okay, all right. So I'm going to actually a methodology here. The only methodology we have discussed so far is to actually look at this multiple cash flow structure and break this into many single cash flow problems. Like in the first, in this previous example, we have a 5-period multiple cash flow structure. What we did was to break this down into 5 single cash flow problems. All right, so I'm going to do the same methodology here. All right. So first of all, let's build a a timeline. All right, so this is period 0, which is today. This is actually in 1 month from today. This person is actually saving per month. So I'm going to have 24 months here. So let me just make sure we have 24 months, right? So, well, that's more than enough. So let me just get rid of that. All right, so 24 months is here, where I'm using copy across technique to build a timeline of 24 periods. So now the next question is, what about the cash flow per period? Well, the cash flow per period, well, that really depends on a lot of things. For example, his annual salary, and then 10% of the annual salary goes to the retirement account, and he's actually doing this at the beginning, and then he gets a salary raise. Okay, so it's all messed up. All right, so how do we go about this? All right, well, his salary increase happens annually, so let's focus on the first year. All right, if you want, we can actually just do some calculations on the side. All right, so in the first year, his annual salary is 24,000. All right, and then he's actually putting 10% of that of the monthly income. So annual salary is 24,000. All right, so I'm going to take some notes here. First year salary, that's 24,000. Okay, so monthly salary in the first year. All right, well, that's 24,000 over 12, so that's 2,000. And 10% of that, so that's 200. Yes? So if you want, you can do this calculation on the side. So this is telling me that, in the first, 12 months, this person is going to save $200 per month. Okay? And now the question is, well, you have figured out one, thing, which is the cash flow amount. So the other thing is, what is the timing? Well, the timing information is also given by the question. If you go back to the question and read it carefully, it says he has decided to put 10% of his gross monthly income into the retirement account at the beginning of every month. So, now I want to actually start thinking about monthly savings. Okay, so that's going to be my second. I'm trying to focus on the cash flows. We know that in the first year, the cash flow amount is 200. But the question is, where do you want to indicate the first 200? Well, we're dealing with a multiple cash flow timeline here. All right, so this is a multiple period of timeline. So this is today. This is also the beginning of the first month. And this time point here, this is, I'm talking about the cell D125. This is the end of the first month. It is also the beginning of the second month. Okay, so, if you want to look at this one here, so this is cell J125. This is the end of month 7. This is also the beginning of month 8. Okay, so if that's the case, I know that the first monthly savings should be here because this is today. This is the beginning of the first month. Okay, so that's the first monthly savings, and he's going to save 200, every month in the first year. So I'm going to start, at 0. I'm going to stop at month 11. Why month 11? This is the end of month 11. This is also the beginning of month 12. So this is the last monthly savings in the first year. All right. So if you actually count, if you highlight all these 200s, Excel says you have 12 monthly savings, which is actually what we expect. Okay. All right. So now you can actually do a little calculation here. Again, second year salary. All right. So what is this person's annual salary now? Well, in the first year he earns 24,000. And then his salary goes up by 10%. So if I do this calculation, 24,000 multiplied by 1 plus the 10%, that's 26,400. And now I can actually say the monthly salary in the second year. So that's going to be the 26,400 over 12. So that's 2,200. And 10% of that, well, that's 220. Okay. So 10% of that. So that is telling me in the second year, this person is going to save 200 every month. Okay, that's the cash flow amount. All right, again, the cash flow timing. So the first 200 is going to be here because that's the end of the first year. That's the beginning of the second year. and this person actually gets a raise, and this person is actually saving 220 now. All right, and now I can actually copy this across, and I'm going to stop here in month 23 because this is the end of month 23. This is also the beginning of month 24. So again, if you want, you can actually count how many 220s you have, and you have a total of 12 220s. All right, that corresponds to 12 monthly savings in the second year. All right, so that is a very important step. Okay, so you see that the timeline approach is actually not fancy at all. You start with the timeline, you start to think about the cash flow amount and the cash flow timing. All right, so what is our direction? Well, this is asking how much will this person have at the end of 2 years. So I'm going to actually look at future value of each cash flow. Now I could have gone this manual approach. I'm going to, just like what we did in the previous example. I could say, all right, maybe I should actually do a little sketch work here. So I'll say future value of cash flow 1, which is the first monthly savings. So I'll do, this is 0 and this is month 24. All right, so this is month 24. Okay, and we're looking at future value. Oops, we know that here you saved the 200, and you want to find out, hey, what's the future value of the 200 here? All right, and after you're done with the future value of the cash flow in the first period, you start to think about, hey, future value of cash flow 2. All right, so in this case, you're actually saving 200 here. This is actually the second monthly savings in the first year, and you're going to have a bunch of months in between. Don't worry about it, and you're going to save 200 here, and you want to find out, hey, what's the future value of this? Okay, so you can do this for 24 times, not a problem. The only problem is it's not efficient. All right, so let me actually finish this anyway, and then I start to think about how do we build a robust formula here. Okay, all right, so listen up. So I'm going to look at the first cash flow, the first monthly savings, and I need to actually get the future value of that. Why? Because this is the early time point, so this is the present value. This is the later time point, this is the future value. Some of you might be concerned about the cash flows in between. Don't worry about them. I'll handle them later one by one. Okay, for now, this is a single cash flow problem. So we're looking for the future value. So from Finance 201, the future value is actually equal to the present value multiplied by 1 plus the interest rate, which is the monthly interest rate, which is 0.75%. That's already monthly interest rate. So no need to actually divide this by 12. And this is raised to the power of, now how many periods do you have time to compound? How many months do you have to grow interest on the first 200? Well, it's just 24, right? Because you start the monthly savings today and you have the entire 2 years to grow interest. Okay, the entire 2 years have 24 months. Every month your money grows interest. So we know that's going to be this number here. All right, so if we were doing this correctly, we should replicate the 239. All right, so bear that in mind. I'm just going to do this, to illustrate, in case some of you are still confused. All right, so here I'm looking at the second monthly savings, which is this number here. All right, it's down here now, and I'm looking for the future value as well. So this again is the earlier time point. That's the present value. This is the later time point. That's the future value. So yes, future value is equal to present value multiplied by 1 plus the 0.75% raised to the power of. So now the question is, how many months do you have to grow interest? Do you have to grow interest on your money? Well, remember, these monthly savings is actually made at the end of the first month or the beginning of the second month. So the first month has already passed. You cannot grow interest on the first month because you have not made the deposit yet. All right, so now you're making this deposit. This is the second deposit. You're making this deposit at the end of the first month or the beginning of the second month. So you have 23 months to grow interest. Okay, because it's a total of 24 months. The first month has passed. All right, so you have 23 months to grow interest. So if you were to do this, feature value property here, you should replicate to 237. All right. So now I'm going to skip the other, cash flows. As we said, that is doable, but it's not efficient. So now I'm going to start thinking about, hey, how can I actually build a strong feature value formula here and to replicate, all these numbers and just do one formula and a copy across. Okay, so you might want to pause the video here for a second and think about ways to do it. All right, but here, this is my, simple way. All right, so I'm doing the future values. I'm taking the cash flow. I'm treating that cash flow as the present value. This is multiplied by 1 plus 0.75% raised to the power of, remember, we should have a 24 here, and the time point we're having here is 0. So what we can do is, how about we just do 24 minus 0. All right, this is a very strong formula. Okay, so let me just copy this across and let me actually paste it here. And yes, this replicates to 237.50. All right, if you look at what Excel is doing here, the way we're using the Excel reference, Excel keeps track of the relative index of the cells, and this is what Excel does when you copy across. Okay, so look at the C126. It's going to become D126 when you copy across to the next cell. All right, and then these are the constant, so they're copied over, and this raised to the power of is also copied over, and then this 24 is a constant, is copied over, and C125 is going to be D125, which is precisely what we need, because 24 minus D125, that will get us 23, and that's what we did here. All right, so this is a very good formula. So now I can actually become a little greedy and I can copy this across. Okay, so feature value of each cash flow here, and maybe I should actually insert one more, row here, and now I can actually say feature value of all cash flows. So here I want to emphasize that this is actually, in this case, it's actually, row 129. So this feature value is actually defined by the common time point month 24 end. Okay, so I'm going to actually, add up all these numbers. Look at the way I'm adding up the numbers, because I have 24 periods or 24, feature values to add up. So look at the way I'm doing this. I look at this number here, that's Z127. I use a colon sign to pick up the numbers in between, and then I go to the very beginning. The first number I want to add up is actually C127. Okay, so Excel is actually using the colon sign to pick up all the numbers between C127 and Z127. Some of you notice that. Can I just do this, the opposite way? Can I sum up, parentheses C127 colon Z127? Of course, it doesn't matter. All right, so that's the future value of the monthly savings at the end of 2 years. Okay, $5,529. Now, some of you will wonder, can I do the future value of each cash flow by doing the future value function? The answer is, of course. So let me illustrate. Again, you might want to pause this and think about, hey, how do you actually do the future value function here? All right, so the rate is 0.75%. And number of period here is 24 minus the 0. And this is a single cash flow. Okay, even though it's a multiple cash flow problem, we're just breaking this down into 24 single cash flow compounding. So the payment is 0. Present value is actually your saving, so I'm going to put a negative sign for this 200. Okay, so yes, I replicate the 239.28. All right, so I can copy this across. I can actually replicate all the numbers. I can even copy this down. I can actually get the feature value of all the feature value of the entire multiple cash flow structure based on the feature value function. All right, so This is a very complicated example, but I have covered all the major steps here, and it should be relatively easy for you to follow. All right. So now let's look at one more example here. All right. I think this lecture is actually getting a little bit long here. So example number 9. All right. So let's just look at this one here, and Tom Adams has received a job offer from a large investment bank as assistant to associate banker. All right, his base salary is going to be $85,000. Very good money here, and this number could be for real. He will receive his first annual salary payment 1 year from the day he begins to work. Okay, so apparently this is the information about the timing of the cash flows. In addition, he will get an immediate $10,000 sign bonus for joining the company. All right, so this is known as the sign-in or sign-on bonus. You sign the offer, this $10,000 is yours. His salary will grow at 4% each year. Okay, very good or very bad. You get a salary growth, but it's constant 4%. All right, every year he will receive a bonus, equal to 10% of his base. All right, base salary, whatever that is. Okay, Mr. Adams is expected to work for 25 years. All right, so we're looking at this, workers horizon. That's 25 years. And how much money do you need to convince Tom Adams to give up this offer and join your company? Assuming the discount rate is 12%. Assuming money is the only consideration this person has in mind. All right, so what's the analysis here? Well, if you're an HR major, this could actually be very relevant. But even for a finance major, this is quite relevant as well, because we're trying to actually bid a job offer. Okay, so what is this job offer? Okay, well, the job offer is really a bunch of cash flows, right? Well, the cash flows, they actually take different forms, because they can be base salary, they can be bonus, they can be sign-on bonus, and so on and so forth. But really, in the eyes of the finance people, this job offer is a multiple cash flow. It's a multiple cash flow structure. So if you want to bid this offer, you need to value the multiple cash flow structure. All right. So only can you bid this offer, only after you have find out, the present value or the future value of this job offer can you then bid it. All right. So, this is a multiple cash flow structure here. So I'm going to start thinking about making a timeline and start to work on, the valuation parts. All right. So this is, year 1, and this person is going to work for 25 years. So let me just make a 25 period timeline here. All right. And I'm going to look at the cash flows per period. Okay. As we're saying, this question is even more complicated because you're looking at all these different kinds of cash flows. Okay. So let me just worry about them one by one. All right. First of all, the base salary. Okay. So this person is going to actually, start working now, but his base salary, $85,000, is going to be paid 1 year from the day he begins to work. So that's $85,000. All right, that's the $85,000 here. That's going to be paid out at the end of the first year. All right, and then base salary increase per year. So we know that the salary is going to grow at a 4%. So it's 4% increase and it's constant. All right, so I'm just going to copy across this 4% here. Some of you will immediately realize that if this is not constant, not a problem. I can still, put down, whatever percentage this person is getting, for the salary raise and put that down for the corresponding year. Okay, and if that's the case, I can quickly find out what's the base salary in the second year. So the base salary in the second year is going to be the first year base multiplied by 1 plus the salary growth in the second year. Okay, so in the first year, the person gets 85,000. In the second year, the person gets 88,400. And actually, I can copy this across to calculate the base salary for the other years. Okay, so by year 25, this person is actually making $217,881. That seems to be good money. The only problem is you have to wait for 25 years to get that. All right, so that's the base salary here. Okay. All right, and then you have the sign-on bonus. Okay, and this is a one-time bonus. It's actually available immediately. So it's actually here underneath time point 0. Okay, that's the sign-on bonus. All right, and then you have the annual bonus. Okay, annual bonus is actually 10% of the base. So I'm going to look at the annual bonus in the first year. So it's the first year base multiplied by 10%. So in the first year, this person gets 85,000. In addition, this person gets 8,500. That's the annual bonus. That's 10% of the base. We're talking about assistant investment banker. If you're talking about the CEO for a Fortune 500 company, then the compensation structure is a lot more complicated. You're talking about stocks, options, option awards, restricted stock units, and a lot of other perks as well. Okay, so I can actually copy this across annual bonus here for all the 25 years. All right, so these are all the numbers that follow. And now I can actually say, hey, what's the cash flow per year, per period for this person? So, in the first, today, well, that's just going to be the sign-on bonus. All right, and then in the first year, the person gets the annual base, and then the person gets the annual bonus. All right, and that's it. Okay, we're talking about assistant banker here. All right, and I can copy this across. I can actually pick up all the other cash flows for the other years. And now what we need to do is to realize that these cash flows, they are actually having their own timestamps. So we need to actually bring them to a common time point. So I'll just pick time point 0 as the common time point. I'll say present value of each cash flow. Okay, I can even actually look at the first sign-on bonus here, and this is now divided by 1 plus the discount rate, which is 12% raised to the power of 0. Okay, because you're looking at the $10,000 today, and you're trying to discount that back to today. So really, you're talking about the same periods. All right, but this formula is a good formula, and I can just copy this across once, and I can actually look at what Excel did for me. So I'm trying to get the present value of the first year cash flow. So Excel is doing the 93,500 divided by 1 plus 12% raised to the power of 1. This is precisely what we need to do. Okay, so now I can actually copy this across. All right, I get the present value of all the other years' cash flows, present value of all cash flows, and that's just going to be the summation of all these present values. And that's just going to be the value of this job offer. Okay, the value of the job offer. So now if you want to bid them, you can actually just add, a bit more on top of this. The smallest increment you can add is a penny. So if you want to be a little generous, you can offer this guy maybe, I don't know, $1 million. Okay, assuming, this is a 25-year contract. Okay, so, that is the, methodology for, valuing this job offer, for beating this job offer. Okay. And some of you will say, can I actually get the present value by doing the, Excel present value function? Okay, so let me just complete this. So I can actually do the present value function here as well. Rate is 12%, and PER is 0 here, and payment is 0 as well, because these are, actually, 25 single cash flow, discounting. All right, feature value is actually this number here. So yes, that will get the negative numbers because the way I signed the feature values. Okay. Oops, did I messed up anywhere here? All right, let me just look at this one here. It looks like indeed I messed up somewhere. All right, so I'm trying to get the present value. So the number period here is 0, payment is that, and future value is this. All right, so yes, I messed up. You know, my future value should not be 153, it should be 152. Okay, and I can now copy this across, and this should replicate all the numbers you have seen. And I just look at, all right, so yes, that's the same number here. All right, so this is example number 9. All right, I hope this is, this discussion is now very clear. If you are dealing with multiple cash flows, you break this down into multiple single cash flows. Okay, in part 3, we're going to discuss the, special cases of multiple cash flows. All right, I think this lecture is actually getting a little long, so let me just stop right here, and we're going to actually resume in part 3.